Good day, you are welcome to this physics class. And today I want to teach you on electrical work, energy, power and cost. My name is Nuruddin Busari. Learning objectives. By the end of this lesson, you will be able to describe electrical work. You'll be able to describe electrical energy. You will also be able to describe electrical power. And you will be able to calculate the cost of electricity. Introduction. As you already know, electricity has many uses in our day-to-day life. It is electricity that we use to lighten our rooms, that we use to power the fans, and so many other domestic appliances like electric stoves, air conditioner, and many more. All of these give us comfort. Not only in domestic appliances, electricity are also useful in factories to power large machines. Without electricity, these large machines used by industries will not get powered. And without these machines getting powered, we will not be able to get essential items like food, clothes, paper, and many other things that are product of electricity. With the introduction in place, let's dive into more details. Electrical work. By mere sitting down and watching this training, to a layman you are working. But to physicists, you have done no work. To physicists, work is done when a force that is applied to an object moves that object, which means without movement, physicists believe you have not done any work. The work is calculated by multiplying the force by the amount of movement of an object, which can be expressed mathematically as W equal to force. W or work done is equal to force times distance. Let's take a look at this example. A force of 10 Newton that moves an object 3 meters. Thus, force times distance, that is 10 Newton multiplied by 3 meters, it gives us a work of 30 Newton meter. We can also call it 30 joule. Electrical energy. Electrical energy is the work done when a quantity of charge moves between 2 points of potential difference measured in joules. So from this definition, electrical energy can be represented mathematically as equal to QV. Q is the quantity of charge and V is the potential difference. Since Q is equal to IT, electrical energy can also be expressed as being equal to IVT. Also, from Ohm's law, we know that V equal to IR. So, electrical energy can also be expressed as I square RT by putting the value of V equal to IR in IVT. Also from Ohm's law, we know that I equal to V over R. Putting the value of I equal to V over R into I square RT, we get the fourth expression for electrical energy, which is electrical energy equal to V square T over R. Let's take this example. Calculate the electrical energy produced by a heater with a voltage supply of 200 volts when a current of 10 ampere passes through it for 5 minutes. Solution. From the question, we were given current I to be equal to 10 ampere and voltage V to be 200 volts. And we were given a time of 5 minutes. Changing 5 minutes, converting it to seconds, that is 5 multiplied by 60 seconds to give us 300 seconds. Electrical energy, from these given values, we will see that out of the 4 mathematical expressions for electrical energy, the one that is suitable for this calculation is E equal to IVT. And that is 10 multiplied by 200 multiplied by 300. And that gives us 600,000 joule. And that can be expressed as 600 kilojoule. By now, as an SS3 student, you should know that 1 kilo is equal to 10 raised to power 3. So there should be no challenge converting 600,000 joule to 600 kilojoule. Electrical power. Electrical power is the time rate at which energy is used up. Power is measured in watts. So power P is equal to work done over time, which is equal to QV over T, which is equal to IV. When you input the value of Q equal to IT into power equal to QV over T, you are going to get IV. Also, since V equal to IR, inputting the value of IR into P equal to IV, we get another mathematical expression to be I square half. And inputting the value of I equal to V over R into I square R, we get the fourth expression, which is V square over R. Let's use this example to explain. Calculate the power dissipated by a heater of 220 volts and a resistance of 10 ohm. Solution. From the question, we were given the resistance to be equal to 10 ohm and voltage to be equal to 220 volts. From the four expressions, the one that is suitable for this calculation is P equal to V square over R, and that is 220 multiplied by 220 divided by 10, and that gives us 4,840 watts, which is equal to 4.84 watts. Cost of electricity bill. The more electric appliances you use and the longer they are left on, the higher your electric bill. This familiar fact is based on the relationship between energy and power. That is, energy is equal to power multiplied by time. Above description can be further explained with this example. The more light bulbs you are putting on, the greater the power you are consuming. You power on 5 bulbs before, and now you are powering on 10 bulbs. So the value of the bulbs has increased. The power you are consuming has increased. Also, before, the longer these bulbs are now on, you were using it for 5 hours before. Now you increase 15 hours, then the time has increased. So energy units on electricity bill is in kilowatt hour. Class exercise. If the cost of electricity in your area is 12 kobo per kilowatt hour, what is the total cost or capital plus operation of using a 60 watt incandescent bulb for 1,000 hours? The lifetime of that bulb, if the bulb costs 25 kobo. Solution. E equal to PT. That is, energy is equal to power multiplied by time. We were given from the exercise that power is equal to 60 watts and the time is what? 1,000 hour. 60 watts multiplied by 1,000 hour will give us 60,000 watt hour, and that can be expressed as 60 kilowatt hour. Now the electricity cost is 60 kilowatt hour multiplied by 12 kobo, which is the price per kilowatt hour. So 12 kobo can be converted to naira by dividing 12 kobo by 100. That is 0.12 naira, and that gives us a total cost of 7 naira 20 kobo. If these bulbs are lighting 5 hours per day, it's going to take about 1.5 years to spend 7 naira 20 kobo. Summary. Electrical work is calculated by multiplying the force by the amount of movement of an object, which can be expressed mathematically as W equal to F times D. That is, work done is equal to force times distance. Electrical energy is the work done when a quantity of charge moves between 2 points of potential difference, measured in joules. E equal to QV. We have also learned that electrical power is the time rate at which energy is used up. Power is measured in watts. P equal to work done over time, that is QV over T, which is equal to IV, which is equal to I square R, which is equal to V square over R. So depending on the question, you choose any of these four equations that is suitable to get the answer for the calculation. So the cost of electricity bill is calculated in kilowatt hour. These are the summary of what we learned so far. Assignments. What is the power of a 100 million volt lightning bolt having a current of 20,000 ampere? Number 2, an electric water heater consumes 5 kilowatts for 2 hours per day. What is the cost of running it for 1 year if electricity costs 12 kobo per kilowatt hour? The third one, an old car has 6-foot electrical systems. What is the hot resistance of a 30-watt headlight in such a car? What current flows through it? Pause this video, write down these questions and solve them. After you finish solving them, send your answers and inquiries to jimosmith@edufirst.mg. Thank you.